When our bodies are injured, healing begins immediately. But healing is not just about replacing tissue. It also depends on the immune system. Immune cells decide whether inflammation continues or whether repair begins. If inflammation lasts too long, it can delay or even block proper healing. Researchers asked an important question. What if we could gently guide the immune system toward a healing mode instead of a prolonged inflammatory state? The team developed a special collagen hydrogel, a soft, biocompatible material that mimics the body's natural extracellular matrix. Think of it as a temporary scaffold that supports cells as tissue heals. But this hydrogel was not empty. It was loaded with tiny biological messengers called extracellular vesicles. These extracellular vesicles were derived from adipose mesenchymal stem cells known for their regenerative potential. Before collecting the vesicles, the researchers stimulated the stem cells with calcium silicate, a material often used in bone regeneration. This stimulation enhanced the regenerative signals packaged inside the vesicles. In simple terms, the cells produce stronger healing messages. When applied in experimental models, the hydrogel helps shift immune cells, particularly macrophages, toward a pro-healing state known as M2 polarization. Macrophages can act in two ways. They can promote inflammation or promote repair. This hydrogel encouraged the repair pathway. Instead of forcing tissue regeneration directly, this approach works indirectly. It reshapes the local immune environment. By calming inflammation and promoting regenerative signaling, the hydrogel creates conditions more favorable for healing. In experimental models, this led to improved tissue regeneration outcomes. This research does not represent an immediate clinical therapy, but it highlights an important shift in regenerative medicine. Healing may not depend solely on adding stem cells. It may depend on guiding the immune system toward balance. Future studies will determine how such bioengineered systems translate into clinical applications for tissue repair. Sometimes the most effective way to heal is not to force the process, but to create the right environment for healing.